No. But yeah,
Yeah.
I mean, we can start already.
Great, great. Well, welcome, folks. We've got Shwet with us, the creator of the Zen-C programming language. And yeah, thank you so much for taking the time today to be with me and sharing the Zen-C programming language.
It's a pleasure to be here with you, Mike, today. I mean, I have to say that, for example, I have watched videos from you before, and it is completely an honor to be here and talk with your community and with part of my community too. And well, I'm sure that this is going to be great. And as Mike said, I am Swite, and I am, well, as a developer and the Sensei creator, we can say that.
Yeah, so I think you've kind of taken the programming world by storm over the last month or two, I would say. I started seeing Zen C popping up on Hacker News. I started seeing other YouTubers. So, I mean, that's why I had to try out your language about a month or so ago, because anything that's new systemsy. I mean, that's something I'm interested in. I think a lot of the world's really interested in that. We've got a sort of
Yes.
programming language boom, so to speak. So, I mean, maybe just to kick us off with a few questions, and then we should actually look at some code since we've got you here.
Okay, sounds great to me.
What sort of, I mean, how long have you been working on the Zen-C project? When did it sort of initially start?
Okay, so this is actually interesting. I started writing Sensi when I didn't even plan to write Sensi. So I wanted to write a kind of C preprocessor on steroids because I love programming in C, and I think it has many possibilities and it is really flexible, but it also has many issues. For example, I used to write libraries in C, and
Mm-hmm.
I like to focus on, for example, zero cost abstractions and a high level feel while keeping that low level control.
Mm-hmm.
The issue is that while those C libs work and they are good for the developer who uses them, for the developer who writes them and maintains them, it is terrible. For the mere fact that we use, for example, for achieving certain patterns and designs, I have to use hundreds and hundreds of lines of macros, hundreds of lines of really specific non-portable preprocessor directives. I have to use specific patterns like X macros, etc. The problem here is that the cost of maintenance for this is geometric. The moment you want to add another function, another method, uh, another struct, you are just you're gonna take a very long time. Mainly because, for example, C, if it is already hard to debug in C sometimes, debugging C macros, it is a complete different level of nightmare. So I wanted to write a simple kind of program that could take some specific custom directives from a specific C file and could then process them and then could emit a specific C code that is standard and it is clean and it works fine. The problem here is that when you start with that, you are like, okay, I will have this feature, I will work on this. There are so many things that you can take, you can explore. And I started, for example, I started on October. It wasn't that long. I started on October working on what I started to call the Zen preprocessor. Um, and the problem I had at first is that it was written in a way that it was really unreliable. It was a string based. It didn't have an AST. It didn't have an abstract syntax tree. Because after all, what I wanted at first, it was simply take a directive, take a raw string of text, and just replace it. And that works fine until you want to create a programming language at the end. So in that sense, um, the problem I had was simply the whole structure and how I designed the language. But then I properly designed the language with the proper abstract syntax tree and many other things. And then in January, I think it was the first week of January, I released Sensi. I didn't expect so much traction. And sure, I shared some content about it. Along December, I shared several code snippets, several examples of what you can do with it. but I expected at most 50, maybe 100 stars. This is funny because you mentioned Hacker News,
Hmm.
and I remember that I posted on Twitter. Yeah, it was on Twitter and on LinkedIn, and then I went to sleep. And the next day, I woke up and I saw a post in Hacker News from someone who I don't know. I still don't know who posted the specific post about Sensei in Hacker News, but it went viral. And then it appeared, many articles were written, and many people start the project. Like I remember, perhaps in the first month, 2,000 stars. The project received 2,000 stars, and it was impactful for me because, after all, this was a project for myself.
Hmm.
Because I had this issue that I wanted to write a specific patterns of a specific design without having to suffer the pain of maintaining C macros, but people liked it.
Yeah, I mean,
I don't know. I said a lot. I don't know if I missed some of the questions you just told me, but well, I mean, yeah.
no, this is perfect. I mean, it's an interesting insight that anybody who uses the, preprocessor for C eventually ends up inventing their own sort of language. So
Yes,
I've heard that
it is
story
that bad.
sort of, yeah. But you're absolutely right. I mean, I'm coming from a D programming language background where there is
Mhm.
no preprocessor for this reason because it's hard to understand. I mean, it has its purpose. It's been a
Yes.
useful tool, but as you said, it sort of started from this problem and it grew into its own language. So have you seen folks then since the Hacker News article or just in the past few weeks trying out the language, getting feedback? Any sort of projects jump to mind or things that have stood out for you?
Well, I remember there are several projects. I mean, there aren't many after all because this language is a few months old.
Mm.
But it actually has a lot more people and projects than I thought at first when I started working on Sensi and when I posted it. I remember there's someone who made a video game. Well, I made a little test of a video game with Relief, which is a great library for C programming language and game development.
Hmm.
And I decided to do it. And then someone decided to take it and completely make a game that I don't think it is currently released, but you go to the community and you can see photos and you can see videos, and it is really cool. It looks I mean, I can look for some photos later, but
Hmm.
it's written entirely in Sensi. Then I remember there's this other friend of mine who wrote, well, friend of mine online, who wrote a web browser
Mm.
in Sensi. Again, the he wrote it with C headers and C libraries. So
Hmm.
that's also the core thing, the core point. Like, you don't need to rewrite the standard library. I mean, there are some great additions that we can do, but you don't need to reinvent the wheel. You can just take Relief or take many other. You can use any library, any header file, and it will just work in Sensi. I remember there's some other people who have worked on Sensi and WebAssembly, and I know, for example, there's a repository out there of someone who made Pong and with Sensi and WebAssembly, and I can send you later the link about it. And what I find more interesting is that there's a lot of people, or at least there are many cases of people showing me how they try to run Sensi in a specific hardware or old hardware, which, for example, I've seen people running Sensi in a Game Boy, I've seen people running Sensi on a Nintendo DS, I've seen people running Sensi on a Nintendo 64 or on a Minitel from a French terminal from the 1980s. That's the power of C after all. Like, sure, with LLVM, you get a lot of power and a lot of optimizations. It is also quite heavy, but my issue is not so much with that. But still, C is a lot more portable, and that's the power of C. It, of course, has its issues, and you have to do it, and it takes time, and it takes sometimes some books take several days to solve, and it is not pleasant sometimes as the core maintainer, but it is doable, and it allows you to get to hardware that you didn't even think about. You, for example, you could surely, it's still in process because I am trying to limit the number of C extensions, the genuine C extensions that Zen-C produces. But you could surely write a program in Zen-C that runs in the PDP-11, where C was created. So that's the point. It is quite powerful in that sense, and you have totally interoperability and portability in many senses.
So the interrupt with C, is that because Zen-C is compiling down to the C language and then sort of interrupting there, um, and sort of generating C code, and you just kind of get that for free? How is that sort of working?
Okay, so many people, I am sure many people here know TypeScript.
Mm-hmm.
I am sure that they surely know TypeScript, and they obviously know JavaScript.
Mm-hmm.
So let's just say that Sensi is like the TypeScript that they have, and what conceptually and technically this is called a transpiler,
Mm-hmm.
which after all it's a source-to-source compiler. Although I think it's we sometimes mix the concepts, and after all, it's more about source-to-destination
Mm-hmm.
code compiler. But we get the idea. We take source code, which in this case is Zen-C or TypeScript. Then we have the compiler, which instead of, for example, producing x86 64 or ARM 64 or different kind of architectures, MIPS, whichever. It simply produces C code, standard
Mm-hmm.
C code or Genius C code. It produces another source code of another programming language, which then has to be compiled properly to the specific architecture and everything.
Mm-hmm.
This design comes with some issues, mainly in terms of debugging at first, because there can appear issues that you don't catch with the diagnostic system with Zen-C, but then because C is going to be compiled, the C compiler will actually catch those issues. And sometimes they can be a bit weird, but we are improving those with the use of as many line directives in which are a C preprocessor directive, which allows you to specify for the compiler to know where, for example, the text and the string of text and the error is, so the diagnostic system works well. Because if not, you will find out that it tells you there's an error here about whichever, but then you will find a completely different line of text, or you will find no line of text, but that can be solved with line directives. But yeah, why? While that is an issue after all, because in terms of diagnostics, it is troublesome. It comes with many benefits, which, for example, I am just a person, and I wrote this in a few months. And I will say the truth. There's more than just one compiler engineering. We can talk about the front end and we can talk about the backend. In this
Mm-hmm.
case, the C compiler is the backend. Although properly itself, it has a front end and a backend, but
Mm-hmm.
in our architecture, it is like a backend. I cannot write the kind of optimizations that the Crank team in Apple or the Genius team can write for a compiler that is decades and decades old with millions of bugs in investments and a lot of time from a lot of engineers. So while I cannot do that, I can take advantage of that.
Mm-hmm.
And that's the whole point. Why writing something that is going to be slower, it's going to be less portable, and I mean, I can just take it for free. That's the main strong point of a transpiler. I don't need to do it all. We can just transpile to C, and we can take 50 years of advancements of features and of ideas and of optimizations for free. I think that's really powerful. And more languages, although there are many languages that transpire to C, but more language or to other languages, more languages should take advantage to that. Also because this is something that is new. This is something that it wasn't ready back when you made the other video.
Mm.
I am currently working on MISRA C compliance.
Mm. Mm-hmm.
So this is an interesting point because while some people, for example, think that you can write a C program or a C++ program or many others, and sure, the C programming language and the C++ programming language and many other programming languages are battle tested and many other points. But if, for example, you write a program for a rocket that goes to Mars, you will end up not using 90% of the features that the languages have. In fact, I mean, if this already happens in C, if you take the 140 directives that you find in MISRA C 2012, which I am not going to mention because it is proprietary, but
Sure.
well, you can
Mm.
say that it is 140 directives.
Mm.
There are many limitations and there are many specific rules that really limit you to a really small subset of C, but which
Mm-hmm.
is still doable. And you can find that in C++ and many other. And the problem here is that that's not so much about having a compiler that it is battle test, which also that, but
Mm-hmm.
having a compiler that passes the specific ISO standard or the specific standard certifications that you can find around. It is a process that takes millions of bugs and auditions, and it is a process that takes many years. For example,
Mm.
I think the Rust in relation with Rust, they are also
Mm-hmm.
having issues with this because they have to um, go through all these procedures and it takes a long time. If it takes a long time for C, which is a pretty simple language, for Rust, which has the barrel checker and all those things, which are totally variable, but at the end of the day, it's more complexity, it takes a lot of time. So
Mm-hmm.
in Sensi, we don't need to certificate the language because Sensi is after all C.
Mm-hmm.
If we at most would have to certify the tool, the Zen-C compiler. But you could, for example, if I could assure you that the MISRA C code that it emits is completely compliant, you could write a program in Zen-C that sends a rocket to Mars.
Mm-hmm.
Because after all, there's like that point. That's also a benefit that I see in the spelling language because you get those benefits from the language. You don't need to work on a specific standard. You don't need to work on compliance to or on specific audits to in terms of the language design because after all it is just C. And well, yeah, I think that's interesting. We could talk more about that later, but
Mm-hmm.
what else do
Yeah.
you?
Well, I think it's just interesting that I mean the TypeScript to JavaScript sort of analogy is an amazing one, and I'm almost surprised more languages don't just target C. As you said, if for one of the reasons is this compiler certification, whether that's MISRA standards, because that's a huge deal if you're going to program something in safety critical systems and so on, which a lot of embedded devices are still going to use C.
Yes.
Um, and we've sort of seen this similar development, I think, in C++ with languages like CPP Front or Carbon. I think while those are still, again, in development, I think they are targeting, C++ code, so you get the interop for free as well. So it's very cool. And I think a lot of people would like like what you're offering in Zen-C, a safer version with some of the more modern features to express our code, write safer code, and then just let the compilers that have existed for 50 years do the hard work.
Exactly.
That sounds
That's the whole
reasonable to
point.
me. Yeah. Great. So, I mean, I guess maybe we should actually look a little bit at the language. I was thinking
Okay.
we could dive in. We've got some viewers coming in, so welcome, viewers. Feel free to ask any questions.
Welcome everyone.
And since I'm kind of a rookie, I thought we'd start us off in the playground, and then you can maybe take us to a professional project later and show us how it's really done.
Okay, yeah, sounds great. Yeah.
So let's see. I'm just gonna go ahead and share my screen here, so everybody can just.
Okay,
Let's go ahead and share my. Well, let's just continue sharing the entire screen here with us, and let's go ahead and just bring out Zen-C here.
okay.
All right. So let's see
So
how
there
that's
are
looking here.
some interesting things here that we could talk about.
Yeah, let's see
Um,
here.
First, that style issue is interesting in the output. That's something I will have to look at. I mean, after all, I am not a web developer,
Mm-hmm,
and after all, I like low levels programming languages because you have the metal, and after the metal, there's just metal. But if we go
mm-hmm,
higher, we have a lot of issues with different browsers, different. But well, let's talk about this.
mm-hmm,
So, for example, here there are some interesting things that we could talk about the backgrounds,
mm-hmm,
about the playgrounds. We can see in the left that we have several missions, but we will leave that for later. Here, for example, if you see the buttons up here, you have the reference, what it says reference code. And if you press at that, you will see a huge list of different examples. All those examples, I think there are over 200 right now.
wow. Okay.
Yeah, I mean, I have to thank the community for those examples
Mm-hmm,
because these are taken directly from, well, with the specific license recognition and everything. They are taken directly from Rosetta Code.
mm-hmm,
If you go to Zen-C category in Rosetta Code, you will find a lot of examples there. And
mm-hmm,
I think I wrote like at most 50 of them. So
mm-hmm,
the rest of them, the other 150, it's people who have taken their time
mm-hmm,
to just offer these resources for, and I really appreciate it. Um, Here, in fact, also because you could say, well, some people could, for example, write programs that are incorrect or other things. Everything is tested. Like
mm-hmm,
I have a specific actions before deploying to test that everything works. I mean, except we have a unicorn, everything should work fine.
mm-hmm.
But
Great.
for example, here we can go to to this example. For example, here we have uh, def, which for the Python enjoyers, it is not a function. We have a manifest constant. Perhaps by this name, this is, for some of you, it sounds like new, but it is really simple. In fact, this is what I was complaining about in C,
Mm,
because the macros are kind of like manifest constants. After all,
mm-hmm,
it's like a label that you take and then you just put. So instead of, for example, you can put size, but after all, that size is literally going to be, in this case, it's going to be 3.
mm-hmm.
Uh, then we have many other things. For example, here you will see down there
So,
the print line,
s-
which I remember before in the other video, you were having trouble with the print line, which is first an issue from my side because the diagnostic error was quite quite obscure, but
mm,
I already improved it. And here, this is interesting because you can write it with print line, or you can remove the keywords, and just the string itself works.
just like this
This,
here.
yes, exactly. This would work
Mm,
fine. Uh, for the people who are wondering why I am making kind of weird scripting language for a systems programming language, this is actually just as some kind of trivia. This actually comes from Holy C, which is
mm,
perhaps one of the most exotic programming languages that you can find out there. So yeah, W.A. Davis
mm-hmm,
decided to use that instead of calling for a function, and I found the concept quite interesting, mainly for prototyping, and that's why it is there. So,
mm,
while for example, if you see right now the code, I know that some people will say, okay, we were talking just about Zen-C and C, but why does it look like Rust sometimes? This is something. This is a comment that I get a lot.
I see these
Why does
functions
this?
and the declarations. Yeah.
Yes, yes. This is interesting because at first I didn't even think about that. I just made it happen. I wanted to take ideas from different languages, Rust, C, Holy C. I mean, you can see there's quite a free buffet over here, and I am picking everything from the list. But well, while some of the people, and I know there are haters about it, will say, but this loses the point of Sense and being C. This is not C. The point is not really about being C. The point is about being modern and taking C as not the language, but as a kind of protocol. Because for a developer, C is a programming language, which is better, worse, but at the end of the day, it is just a language. But in terms of architecture, for me as an architect, it is really useful because, as I said, you can find a lot of hardware which for example C works in many hardware many different kind of hardware, different kind of architectures, thanks to 50 years of a lot of work and progress and the simplicity of C in a sense, and many other things. But well, we can take that portability, and also that this is really useful. For example, many languages like C++, D, uh, C, Lua, there are many languages. They have a somewhat robust or somewhat complete interoperability with C. And that's really useful because it allows us to, for example, uh, take instance, run C++ code or run Objective-C code or CUDA C++ code or CUDA C code with just a few changes in the source code, which can be done by doing a few changes in the compiler. But besides that, let's, for example, I think this is interesting because this is something that there's really little documentation about it. If you go to the last mission, to the BrainFuck masterclass, well, I don't know if I can say that word in, in YouTube, but
Safe here.
it's
Go
the
for
name of a programming language.
it. It's purely
So,
academic here.
exactly, exactly. So this is something interesting. So here we have two files. We have the main one, which does this, and then we have the plugins one. If you press run, although I don't know if in the output you will see that, but it
Let's
should print, uh, I don't know if it shows, I'll try to run it again perhaps. It should print, I don't know.
me.
Perhaps it is an issue with the playground. Either way, I will have to check it. But I mean, perhaps I can
Actually,
show it.
do you want to share? I could share it on your screen
Yeah, I
maybe,
mean,
and
either
let's
way.
go for that. Yeah, maybe that'll
I
be
mean,
easier. Because I'm really
either way.
curious what this program does.
Yes, yes, it is quite esoteric, but it is interesting to. Okay, let me just try to share screen here.
Yeah, I'll let you share screen, and let's see if I stop here
Okay,
just for a moment.
yeah, yeah. I mean, everything has to be improved, but after all, that's the joy of it. There's
I
nothing.
I mean, I think it's amazing how much you've gotten so fast, and also just, for folks building a new programming language these days, it's also an interesting observation that you have to have the playground, you have to have the documentation, you have to have a whole ecosystem. Maybe that's another conversation to talk about. How you sort of maintain, develop that. You just already mentioned you have the test suite and so on. So there's a lot that goes into getting this working. And yeah, I see it's working on your end. I'm probably
Yeah,
just clicking
it
the
is
wrong
working
buttons.
here. I don't know what's the issue, but it is fine. I mean, um, okay. So I mean, I don't know if right now I only see my screen like with the playground. But if
Perfect.
you're
Yeah.
seeing right now, this is interesting because in Sensi, besides many other features that Mike has explained really well in his other video, which you have to totally watch. It is pure content, amazing. Uh, we have a plugin system. And how does this work? Well, this is actually quite useful and quite dangerous. Uh, for example, well, I give you a, if we come here,
Hmm.
you will see. This is literally okay. We come here. This is literally what it takes. This is the plugin. It is. It's not really that long in this case because even though this esoteric programming language is esoteric, that doesn't mean that it has to be complex. It is quite simple. For example, what we are seeing right now as a plugin, it is just uh, we are having an interpreter or a compiler. We are having a parser
Mm-hmm.
inside the programming language. So we have a programming language for programming languages. That's something that I think other programming languages do in different ways. I think there's this one, Racket, or I don't remember how
Mm-hmm.
it is called, but it's like it allows you to write your own programming languages or in another programming language. For example,
Mm-hmm.
here there are several points that are interesting to check. For example, you see these weird symbols here.
Mm-hmm.
If we come here, we can see this one is the reference and the post increment, and we just increment the data pointer because this is like kind of like kind of not really, but it's just like a state matching. Think about an array and in which we have a pointer and we can do additions
Mm-hmm.
or we can do increments or decrements. And that's pretty much what we have. And this is Turing complete. This is Turing complete. Although this is considered a Turing tar pit because sure, you could make anything with this. I could in fact rewrite Zen-C, the Zen-C compiler in this programming language, but it is so and not useful. It is
Mm-hmm.
such a waste of time that it doesn't make sense. But it is totally possible. Like for
Mm-hmm.
example, the PowerPoint or Excel, those are also Turing complete. You could make a programming language with those. And
Mm-hmm.
here you can find, for example, we just need a pointer that we move a value in that pointer which we increment or decrement, for example, for characters, or and we just need to print it or to read it. And
Mm-hmm.
we need loops because if not, well, we need some kind of control flow. But besides that, what you just saw earlier, we the plugin system has access to the well, to both the diagnostic system and to the LSP, which is something that I haven't talked that much. But we have an LSP working. In fact, the
Mm-hmm.
playground itself is working with the LSP,
Mm-hmm.
everything you're seeing. But this is actually quite hard. For example, this is the reason why in C, the macros don't give you any information, or in many other programming languages. Like when you try to put a programming language inside another programming language, the language server protocol is not going to handle it well if you don't rewrite it. If you don't, in this case, I have to design it in a way that whenever it sees, we come here, whenever it sees these plugin blocks, it
Mm-hmm.
tells the LSP where it specifically is, and it gives control to the plugin to for example, for syntax highlighting, or for giving information, or for diagnostic errors, for many things. It can be quite useful because this is something that I haven't seen in many programming languages that try to have macros or um other programming languages embedded, and that's quite an issue because it is really hard to write, really hard to maintain. But this way,
Mm-hmm.
we just need to define this plugin. We just need to define this, and this is all it takes. I know that in other programming languages, like in Rust, you have, for example, you have the Rust macros, which some people would say, okay, this kind of reminds me of that. There's a big difference between Rust macros and Zen-C macros. And
Mm.
that's also where that power and that's also why this is dangerous in a sense, but it is really powerful.
Mm.
What happens here is that it we literally take a string of text, we give the string of text raw to the plugin, and it outputs a raw string of text,
Mm.
which in this case is this C code.
Well. Mm-hmm.
It's this, but it is that simple. In fact, this by itself, this plugin, it is a programming language for the people, for example, because there are many people who think about compilers or think about programming languages as they find it as those black boxes, which are quite complex um, to to see, to work with, and to understand, to comprehend. For example, you can have a programming language in 67 lines. Uh, in 67 lines. And no, no pun intended. I just saw that it was 67. I don't know. My little
Yeah.
brother, when he watches this video, uh, poor me. Uh,
I mean,
and,
folks are commenting in the questions, about the difficulty that can be to put together a compiler with all the passes, optimizations, and so on. But I mean, this is a nice
yes,
example of this could be a
yes.
place to start, and a tiny language like this. But yeah, it's interesting to see the language embedded in a language here,
Mhm.
um, and as you mentioned, the thing that came to mind was thinking in Python, okay, we have like documentation strings, or some languages attempt to, add this sort of stuff, but adding it on the actual operator there is interesting. And I wonder if that came from your experience of where this project started initially with the preprocessor and how everybody invents their own language. And so now you built in a
Bingo.
feature that says, yeah, we have to, if everybody's going to be inventing their own language anyways, like
Yeah,
you have a tool
exactly.
to document
Yeah,
it.
in a way, the programming language is a toolkit for programming languages, mainly because I found myself that some of the issues that because sometimes people categorize programming languages as Alexa, which means take a raw string of text and tokenize it, a parser, which is the part in which we actually make the logic, but it's not that hard. I mean, it depends on the kind of programming language that you are working on and the kind of set of that programming language or how your programming language is. But it is not that hard. In fact, later we can see an example of something more professional than this, but it is often like the lexer,
Hmm.
the parser, and the code generation, the coding, which, as the name says, it is just taking what you processed, what you parsed, and just emit something, which
Hmm.
that something in this case is C, in some cases is x86, RISC-V, MIPS, whatever,
Hmm.
JavaScript, whatever. But there are some important modules which I think that are really important nowadays for
Hmm.
languages. First of all, although this is not just from nowadays, but for decades already, it's the diagnostic system. And
Hmm.
that's something that sometimes it's not so mentioned. I don't know if that's because some people who design programming languages, they design them more academically and perhaps they don't think so much about the user. It also depends. Like there are many programming languages, but it is something that perhaps it is not mentioned that much
Hmm.
or separated that much as its own category. And then the other part, it's the LSP. Because sure, you can take a Notepad, or you can take a Beam, or Nano, or Emacs, and you can start writing without any information.
Hmm.
And sure, that works. I have done that many times. But if you are going to work on it, and if you're going to use it professionally, you need to get several features that we have here, like just syntax highlighted. That that is really useful. Seeing the diagnostics in the right time, or seeing
Hmm.
many other things. And in this case, Sensi gives you that for free. So you could design your own programming language and use the core diagnostic system and the core LSP for
Mm.
free. And you don't even have to write it. I give you, in the API, I give you some function pointers, which then you have to associate with the function. That's all.
Mm-hmm.
And it is quite useful in that way. But after all, yeah, a programming language is just take text and produce text for the people who are watching. It is there's some things happening in that black box, but it's not so much of a black box, and everyone could make a programming language. If you're watching this, I am sure that you are the kind of person who would certainly be able to write a programming language without much issues. But yeah, I mean, what were we saying?
So, so I guess I mean I just want to touch on a point
Mhm.
or maybe an observation. I mean, you've got a love of programming languages, and you're even giving people the capabilities. You know, this these meta programming, or I mean, really just built into the language here to design their own languages. Did you initially get interested in computer science? Did you read a compiler book, or you know what kind of got you into designing languages? So I just want to kind of learn a little bit about your history, and then maybe we'll dive into another language that you're building in Zen-C here.
Yes,
Just
sounds
for
great to
folks who are
me.
interested, yeah.
Well, this is something that it is interesting. Well, first of all, I don't think the playground is needed anymore. So I mainly to see you because right now I'm seeing the playground.
Sure, sure.
Let me, yeah, let me come here. Okay, good. And so now I can see you. For example, this is interesting because some people will think that okay, he's writing a programming language. He has a lot more experience than I do, or whatever. I don't know
Right.
what is passing right now from the brains of the people that are watching us. I am just a 19-year-old. I didn't even finish computer engineering, which is what I am studying right now. What I am doing is, well, how did I start doing this? First, by skipping a few classes, which is something that different everyone. But yeah, but mainly about the resources and everything. I am I am not an expert. I am not knowledgeable in many topics, but I'm a curious person. So I thank God that I was born in the time I was born, and I have a lot of resources online. I have many tools available. I have if I could have any question right now, there's a 99% probability that there's a way for me to find an answer for that question. I remember I didn't even start with programming languages. This was just a side effect of wanting to write C libraries. But I started, in fact, with C++, because that's what I learned in university. And I was tired of the kind of small projects that you get in university, at least in mine. And I decided to, for example, write an operating system. And I know when I started, even right now, because right now uh, I still need to read a lot of resources. I am not an expert of the matter, but I decided to take a tutorial, watch it, and start writing an operating system. And you could say, but weren't you ready? I can share, in fact, the link of the. I have here the YouTube channel. Write your own operating system. It is great. It is great. You have like several hours and hours of writing an operating system in C++. So there are something that I found people both online and both in my classmates is that I find those two main positions. Either one of them is you don't feel like you're prepared enough for working on a topic like an operating system, which is totally understandable. So you decide to take time and give time and be like, okay, I will be prepared in some years. Or okay, but sometimes it's just putting yourself to do it. And in the pain that you get in the process, it's when you get that skill. And then I find other people, which I think that that's perhaps the most worrisome part. And I found it quite often that there are people who think that you just have to program in university. After you leave university, you don't have to program anymore, or you do your homework, or sometimes do because I found many people who don't decide to do that kind of stuff. And
Yeah.
I find that worrisome because you're studying computer engineering, or you're studying computer science, or you are doing a course related to this, or to a programming language, or whatever. If you're here, you should be here because you want to learn. Because, and you, sure, they are there for to guide you, they are there to help you, but you need to put your time to, for example, write whatever that comes to your mind. It doesn't have to be hard. It doesn't have to be an operating system, a programming language. It just has to be something that you say, okay, I have this question. How do I do this? How do I solve this? How do I, can I do this? I don't know. I think you have to look at programming just as a kind of puzzle, a kind of like Sudokus. You just solve them not because there's a something behind it, which of course there is, but that's not the point. You're solving it because you like solving Sudokus, because you like
Mhm.
programming. And about the resources, well, there's the YouTube channel, Writing an Operating System. I think that's how it is called.
Mhm.
That write your own operating system. That channel is great. They also have about a lot of resources about Linux specifically, Unix. It's great. Then, for example, for for learning how to program a compiler or create your own programming language, I remember there's this great resource. This it's called crafting interpreters.
Mhm.
I think it is a great resource. It is quite simple. If you have, for example, some knowledge of Java, or if you have knowledge of C++ and C, it is divided into sections. In the first section, you write the interpreter. In Java, in the second section, you write the interpreter in C. It is great because it goes through the whole process and it gives a lot of information that it is quite useful. So you don't only live with an interpreter, but
Mhm.
you live with a lot of knowledge. And I think you can buy the PDF and you can buy the book, but I think it is totally free online. So it is something that you could start right now. Like
Mhm.
after this video, you could totally start writing your own interpreter. And it is a really enjoyable ride. I know there are some books that can be heavy, and while I'm not saying you shouldn't read those, there's many of those books which are great. I understand that if you just do it to learn or just to as a hobby or to spend your free time, that the crafting interpreters book is quite nice because it is really enjoyable to read. It's not like you don't feel like you are working. You feel like you're just playing around.
Mhm. I can't tell you the number of times I've recommended folks Robert Nystrom's book, both of his books actually, but the crafting interpreters, and then we've got a lot of game programmers on this channel, so his game programming patterns book. I always tell folks that it's one that both books I read them online, and then I liked them so much I had to buy a copy on my bookshelf. So yeah, definitely
Yeah, right.
for the students out there or folks just interested, check those out. I second those recommendations.
Yeah.
So okay, so that's really interesting and inspiring to hear your story about kind of just diving in and sharing some of the resources that have been helpful. um, I wonder if we can again share a screen, and since we've got the expert here, I've followed some of your posts on social media about this compiler that you're building in Zen-C. So I'll leave folks with that little teaser, and then maybe you can show us and talk about this project here.
Yeah. Sounds great to me.
Yeah.
Let's have some fun, because yeah, sure we can. Like I was telling Mike before, we can go to the playground and we can see examples that you already have there available that are maybe 50 lines long, maybe 100, and sure they are useful and they are great to
Mhm.
understand the language. But what is a language without a compiler? So let's see a compiler. And first of all, here today you're not only going to learn about Zen-C, you're going to learn about B. What is B? B is a quite old programming language. If C is old, B is older. Interestingly, because I know that some people will think about that, the antecessor of B is not A, it is BCPL. Uh, and I have to say, I think it was written, or at least the manual, the language reference. Okay, let me open this. The language reference it's from 1972, so it has its time. and it was written by Ken Thompson. And in fact, here it is. In fact, when you see early C code, you will see that there's a lot of okay, share screen here, and with this stuff. Okay, this should work.
Yep, we see you live here.
Okay, so for example, let's see. We have this. There's a lot of stuff right now because I am a quite messy person. I need to organize myself better. But let's see. Here right now I have several test files which we can clearly see. Like we have here the wait, that's interesting. That's because Badcat doesn't work well with light theme. By the way, for the people whose eyes are burning because of the terminal, because I know that a lot of you like to see the terminal with light. Wait, actually, we can solve that later. But yeah, I hope you see well. Do I need to? Okay, whichever.
I think that's looking pretty good. I'll monitor the chat if anybody needs bigger fonts here.
Okay. For example, this is a program in B. For now, it looks quite like C. Perhaps the main issue that you can see, although it was valid C code back then in ANSYS, like in C89, C90, I think it stopped being valid in C99. You will see that the main function, what's the issue here? That the main function doesn't even have a type. What happens here? You could say, okay, it should be int main, and we should return 0. Or although we can do it implicitly, but whichever. The problem here is that B was designed with the PDP 7. C was designed in the PDP 11, B was designed in the PDP 7. What's the difference between the PDP 7 and the PDP 11? That the PDP 7 only has a type, a data type. It only has words. So B is fundamentally a typeless programming language. And that might be something weird for some of you, but let's just say that everything is a word. In this case, because I am working on a system that is x86-64 Linux, well, I decided that the word is 64 bits. But I don't remember exactly the size of the word, but it can vary. But then, if you check, for example, if we come here, let me show you. Because we have here the compiler in B, okay, compiler in C, which is a bit big. It is, I mean, for a side project, because I started this on Wednesday, it's not a bad size. It's not the complete B language. There are many things that I didn't add because after all, in 4 days you cannot make a whole programming language, although we already made a lot. But then if we compare this with, for example, here I have it. I have to change the name here. It is really different. It is a lot smaller. In fact, we can just go after. If I do this, does it? Do you see it well? I changed the
Yes,
size
perfect.
of the. Okay, perfect. Let's start by comparing, for example, how the compiler in C would be and how the compiler in Zen-C would be. But first of all, we have the compiler in B, or kind of, because I didn't have B as a complete set. So, for example, there are some things here that are interesting that we should check. First of all, we have an issue in B. B doesn't have structs. B doesn't have unions. B doesn't have many of those structures. So here we have to do some messy things, which is like defining these global constants, and then we have to initialize them. If we, for example, come here to the C compiler, the compiler written in C, There are many comments. This is just me without enough coffee. You don't have to worry about the comments. For example, what we defined earlier as that weird list of mm, global constants, here we can define it with an enum,
Hmm.
and here we have all of these values. Here I mentioned the PDP-7. This is also important because if we come here, you will find that here, for example, if we go here to the next token, we find this keyword, the auto.
Hmm.
This is not the C++11 keyword. This is not the C23 keyword. It is closer, in fact. This is some kind of trivia for related to C, yes,
Hmm.
because why not? Uh, in B, to declare a variable, and for it to be in the stack, you use the auto keyword.
Hmm.
And C originally has this keyword too. But there's a problem, and that there's a reason why you don't see this keyword ever being used. I hope. Uh, I mean, it's not really an issue, but it's just the fact that by default in C, you will see that all the variables you, for example, int length or float number, whichever, those are already living in the stack.
Hmm.
So we find this, which is interesting because when they were writing C originally, they kept the keywords, but was you could use it, but it was just like saying this lives in the stack, which was already the default behavior. So then they removed it and then they gave it a different purpose. But it is interesting. Okay, now if we come here, okay, this is not production ready. After all, this is just me watching a video. I don't know if you have watched, if you know, well, obviously you surely know Computer File, the channel.
Hmm.
So they published a video about the B
Hmm.
programming language like a week ago, and I saw it, and I was like, okay, this is interesting. In fact, I talked with the person who appears, Angelo, with the person who appears there, and there's a main difference here from his B compiler and from mine that he wrote the B compiler he uses for the PDP-7.
Hmm.
I am writing it for my machine. So if I will later release the source code for this, but you will certainly see some different approaches that I have to take because they are completely different architectures. But yeah, I recommend you checking that video, and I recommend you. I mean, it is really interesting, and
Now for the
I mean, I wouldn't.
PDP. Oh, sorry.
Mhm.
I was just gonna ask. Is that architecture still an 8-bit architecture, or are we talking, old machines that had like 7 bits, or where a bit wasn't even,
I
or a byte wasn't even 8 bits here?
I don't remember. That's a
Yeah.
great question because I don't remember, but I cannot tell you the exact size of the words because after all,
Hmm.
didn't have bytes per se. But I
Hmm.
think it was a non-standard like size. It was
Hmm.
perhaps 36 or something like that. I do not
Right.
remember, but it was not like we have machines right now, which we take for granted that we have bytes, we have perhaps. But if we go back there, it was a whole chaos. In fact, if we talk
Hmm.
about going to back then and seeing some chaos, this is another interesting trivia. I mean, this is I know why I came here to talk about Zen-C, but I just like programming, so
You're in the right audience.
um,
Yeah.
yeah, I'm glad to hear that. And for example, this is we can see this actually from this. You will see this the printf, which by the way it's the C printf. I take it from libc. I will later explain how I do that. But you will see here, what's that after hello world? You
Hmm.
would certainly expect a new line, but there's a problem back then with the machines they used to have and the keyboards and everything, that the backlash key, the backlash character wasn't available in many keyboards back then,
Hmm.
in keyboards back then. So and it was, it was the 1970s, early 1970s, and in terms of standards for hardware and in terms of standards for architecture software, it was a full chaos. So Thompson and Ritchie decided to go for this. They decided
Hmm.
to use the star key to as a escape for the escape sequences, which then they decided to remove because after all, when you then start to write some heavy arithmetic code, you will find that, for example, you for every multiplication you will have to write twice the character. Like if we come here, we come here. For example, here, here, for example, in the B compiler written in B, you will find some of you from other languages will see this at first and you will think, okay, this is like powers, or this is like, no, no, this is because this is a script sequence, and this is as if you wrote this, but well, they decided to remove this mainly because after all, then well, keyboards started to come with the backlash, and okay, that's interesting. And they started to be standards and appear like. But this is interesting because if you ever see B code, you will find that. And here, for example, to explain how much, how little of a subset this is in the 4 days that I have, you will say, okay, why did I you write four and 5 ifs? That's because I didn't even have time to write the answer, the operate like logical operators and bitwise operators and many
Hmm.
others. So here we are. It's not okay. It's not that I will improve it, but this is what we have. And for example, while I said before that some of the functions that I use come from libc, for example, here we have some implementations from some of these functions. Another bit of trivia is that in B, you don't need to care about the how you put the functions. Like you
Oh.
can put a function that you call before. Like you can write an implementation without a prototype, and you could say, for example, here we have init tokens. If you we call in init tokens is a space for some reason,
Hmm.
this wouldn't give an error, which in C would give an error because we don't have the definition and we don't have a prototype. But there's a reason for this.
Hmm.
And there's a reason for why C requires prototypes or requires a specific order. That's because in B we only have one type. So if you see that you call a function like here vchar, you know that it will always return the same thing because there's always one data type. So you don't need to care about the order because in C you would be like, okay, you have this definition here of is a space, but the compiler sadly doesn't know what this what it returns. So you have to put it in order. But because in B we don't even have types, or we only have the word type, you can write the the functions in the order you want, which is something that you will say, okay, this is from modern programming languages. No, B, which is over 50 years old, already supports this. Um, okay, okay. But let's go now, or let's try. Yeah, let's do it like this. We should have, I don't know. Okay, that's interesting. So we come here, and I already have everything because I already tested it before. Or we can come here. This is what it emits. This is, for example, the hello world example that we saw before. This is how it works. It is rudimentary. I have to hand roll the assembly, the code generation. In fact, there are many things that could be improved. For example, having here sections in the middle is ugly. You shouldn't have sections in the middle. You should have some kind of organization, but it works. It works with NASM, which is the tool that I use. For example, here we come here, we take this. Wait, well, yeah, we come here. Okay, and this just works. Then I compile it. This is interesting. I compile it with, although in this case this wouldn't be necessary, but whatever. I compile it with GCC because I use the C libraries. I use the libc because as you saw, I don't have a definition for printf. So what I do is literally just compile this, and let GCC link the object that I have with the specific C functions. And
Mm-hmm.
this is troublesome in some senses because there are many issues that can come when you try to write a when you try to mix a types programming language with a typeless programming language. But in this case, it doesn't come with an issue, so we can do this. And it prints hello world.
Mm-hmm.
This. Um, but this comes with some issues. If we, for example, we come here, here, I have to define what I call a peer runtime library. What does this
Mm.
mean? So, as I said, B doesn't have types, but C has types. This is the main reason behind this is because BCPL didn't have types, and B didn't have types because the hardware didn't allow it, because the PDP-7 didn't allow it. But then when they moved to the PDP-11, they could have bytes, different sizes for data types, and everything, so types were introduced. Um, but here's a problem. For example, this is something that I had to fight yesterday. Was it yesterday? Yeah, one of these days, which was with getChar, a simple C function, which you would say, okay, it returns an integer, which shouldn't be an issue. But the problem is that getChar is a 32-bit C function. What does this mean?
Mm.
It means that it returns an integer, an int, 32 bits. The problem here is that I have my words as 64 bits. And the problem is that the ABI doesn't guarantee that the upper 32 bits are have the symbol extended or are cleaned or everything. So it can be anything. So the problem here is that getChar either returns like 0 or -1. But -1, if we know a bit of basic computer engineering, or well, if we know a bit of how the hardware works and how the system works, we know that -1 is it uses to complement,
Mm-hmm.
and it is pretty much a 1 1 1 1 1 1 1 1
Mm.
complete. So you have 64 bits with one. The problem is that, as I said, you would get the 32-bit version of that. You would get 32 bits of one. But then the other 32-bit would be whatever. So if I am not wrong, because of the how the ABI is defined, you instead of returning -1, it would return over around 4 million positive. So that's something that you have to look for when you're working with this kind of stuff. And to solve it, pretty much I have to just solve it with a return and define the specific type. I had to do some casting, etc.
Mm-hmm.
Then another issue that I had was with, for example, with character and the strings, which is also one of the reasons that Richie and well, when they were working on C, they moved for having types, which is, for example, having strings. For example, a character is one bit, 1 byte. A character, if we are talking about ASCII, or perhaps 128 if we are talking about the subset, but
Mm-hmm.
it is 1 byte. The problem here is that because we only have a word, which in this case is 64 bits, instead of using the 8 bits, which is what we need, we end up using 64 bits and only having one of the bytes with the value, and the rest is completely waste. So to solve that, I also define this to, which in fact I do it through C, but I think that if you check the B language reference, there's an implementation for this, for handling strings and everything. So in this
Mm.
case, I just have a function which has an index and a pointer, and you just move through that. Uh, you move through the word as if it was. I can do this because I have C, but if not,
Mm.
it would be totally different. But yeah, right now I only need this, and I only need the libc. But with that, for example, you can compile the B compiler, which then, if it is complete, you could compile the B compiler with the B compiler source code written in B. And this is like a tongue twister In fact, I
Mm-hmm.
remember I told about this yesterday to some friends, and I have like a it was like a hundred words for explaining how what bootstrapping is. But let's just say for those who don't know much about, who are not so knowledgeable, which is understandable, about programming languages, one of the points about a programming language, or to show that it is robust enough or that it is ready enough, it's to bootstrap it, which means that
Mm-hmm.
you can compile your compiler with it. And you can have the source code of your compiler in your programming language, which is what we have there. And but that's not the point. I mean, with P, although it is more complex than the esoteric language I showed before, it is still quite simple. With Zen-C,
Mm-hmm.
that is going to take time. I have people already asking me about bootstrapping,
Mm-hmm.
but uh, Zen-C is a lot more complex, which is also
Mm-hmm.
it is also why I love it. But it is going to take time. It is going to take time, and mainly because I have an issue with it. Well, not an issue. It's like it is my child, and okay, let's talk about Sensi, but with the source code in Sensi.
Yeah,
Uh,
I think folks will be curious to see the
yeah.
compiler here and just how different the source is. And
Okay.
I mean, we saw the source reduced by about a third in line count. So surely there's tools for expressing um, programs in a more concise way here.
Just to make it clear, as you can see here, I could have. It, it is three times less
Mm-hmm.
size, less lines, but you can say that I have clearly not optimized it. Like you can see this
Yeah.
enum, and you can say, okay, but this is good. This proves that the rest of the logic is quite. So here I have the
Mm-hmm.
enums. Here I have the struct, and since the struct is just a C struct. Let's just say so.
Mm-hmm.
It is not like in, for example, in C++, which, for example, you can find the methods and you
Mm-hmm.
can have that OOP stuff, which, well, then if we start talking about how Java and how C++ implement OOP, we might get in some muddy places which we don't want to get in. But
Sure.
let's just say that in Sensi, a struct is a C struct.
Mm-hmm.
And here we are, for example, using some useful stuff. While in the other side, I have to define the specific specific structs, which can be, well, I can show them later. Here, for example, I can just use some of the objects that I have in the from the Sensi standard library, like this string, which we can see later, and it's really useful. We have vec for vectors, which, as you can see here, it is, which this is also why one of the reasons why I started Sensi, for generics, because
Mm-hmm.
C is great, but C introduced a lie. So one thing I don't like about C is that it introduced a lie, because when you're learning C, you see there's this the underscore generic,
Mm-hmm.
which is a preprocessor directive, and you are like, okay, with this I can write generics, but no, it is pretty much for function overloading.
Mm.
I don't know what happens there in the committee, in the standard committee. I have to do some research about that, but they are not really good with names. I mean, I love what they are doing. I think they should perhaps introduce some. I understand that after all, C is a language that cares. It's important to think about it as about legacy and
Mm-hmm.
fallback, like backwards compatibility and other things, but they are going a bit slow. But I mean, I think only in the last standard, the C23 bool, the keyword bool started to be reserved, because before you only
Correct.
have
Yeah.
underscore bool, which, because some people get confused, bool existed since C99, the data type. When you include std bool, you are not
Mm-hmm.
including a new data type. If you see it's just a wrapper
Mm-hmm.
of the bool and just defines the keywords. Because the problem here, which I understand for when it was back then for C99, which is, for example, many legacy code bases have their own implementations of pool. But
Hmm.
I mean, it's been 20 years. I think we can move on. And
I think we're ready for it. Yeah.
but well, it is what it is. I mean, at least they did it.
Hmm.
And here we have some things. As you can see, even though this is Zen-C, we can use C functions. We have
Hmm.
here malloc. There's no issue. We have other things like here we have a string new, backnode
Hmm.
new, a backstring new, but you can use any C function here.
Hmm.
Um, for example, and one of the things here, as I haven't mentioned, this will give you really strong Rust vibes. I know,
Hmm.
I totally get it, but it is quite useful, in fact, because while you would have to be passing the besides the syntax, it is quite useful because I like to have some OOP, object-oriented programming feeling, but I don't like to get so much into it. Not because I dislike it, but because I think that I like things simple, and
Hmm.
this is actually pretty simple. I can explain how this works because
Hmm.
in other languages like C++, maybe you have a virtual table, you have all those things. They can add overhead. It depends. That's more for polymorphism and for other
Hmm.
things. But it can get complex, and that's something that I love about C and I dislike about other languages is that C, if you see C code, you can surely understand what is happening in assembly,
Hmm.
but if you see C++ code, that's a lot harder. If you see code from many other programming languages, I don't know about D. That's something I have to ask you. I don't know how because about I don't know that much about D, and I am
Hmm.
curious. How well does it for you when you write D? Can you know or can you feel what happens under the hood?
For
Or
the
like,
most part, yeah.
okay,
So I mean, for like a struct type, for instance, which is a value type, that's gonna pretty much translate one to one for the assembly now. And especially if you're using the better C mode, which kind of
mhm,
strips some of the runtime away. You're pretty much looking at the same thing if you were to handcraft or do object oriented type of C. As soon as you have classes, though, it can get a little bit
mhm,
messy with the assembly because, again, then you have your virtual functions. You can start overriding things. So I do like when languages, and I think this was a good thing with D, do at least distinguish struct and class so you have some control. I mean, just like you've done here, you were showing a struct, and in my mind, that's like, okay, that's a record like in Pascal or something, right? It's just the data type or just the aggregate data. So, because I'm actually curious to see what the implementation of Node here, I'm assuming that's just going to be a function and then I could just see the one-to-one like label in the assembly, and
yes.
it's just
I
going to
mean,
translate nicely. Yeah.
yeah. Well, besides name mangling, that's an interesting topic you have introduced.
Hmm.
If we talk about C++ and name mangling, we can get into some. Let's not talk about C++ name mangling because
Yeah.
many things are happening over there that we don't want to
Hmm.
see. But here it's pretty straightforward.
Hmm.
And for example, here you see node new. For example, you see the method new.
Hmm.
This would be transpiled to a C function, which
Hmm.
would be node underscore underscore new underscore underscore, and then it would be the
Hmm.
type that it returns. Some could say, okay, then I could define my own function that it has the same exact name, and I could introduce a collision. Yes, technically you can do that, but you would have to do that consciously. So
Hmm.
I don't see a reason why you would try to do that. But like with the, I mean, it has some certain points, like in C++, which in what I said that it is messy. At the same time, it is quite useful in terms of
Hmm.
preventing collisions and other things. But I found out that while it is useful, it is quite complex, and many times you don't those collisions sadly just arise because you consciously
Hmm.
try to generate them. Besides that, I am also thinking for the future to enable some optional, better, more random, well, random or pseudo random name functions for name mangling, so we
Mm-hmm.
prevent all kinds of collisions. But after all, I don't think it's like a main issue. This is interesting
Hmm.
uh, about well, C++, because not that long ago, I met, I don't know how to say the name. Like, I remember when I met him, it was like we talked about it. I met the creator of C++.
Oh, Björn Strustrup. Yeah. Yes. Yeah.
Exactly,
Hmm.
exactly.
Hmm.
Mm, and I think this is something interesting because many of the criticism that I can do about C++, it is perhaps criticism that Björn himself can do
Hmm.
about C++.
Hmm.
As far as I understand, well, this is what happens with standard committees and with
Hmm.
everything, that everything gets really conservative. And as far as I understand, first, he is not the conservative part in the standard committee. He would like to do a lot more about C++ than
Hmm.
sometimes it is done. Um, and besides that, it's because he gave me a lecture about modern C++ and
Hmm.
how C++ would go in this decade.
Yeah.
And I find it interesting because the main criticism he has is that he says that there are new standards, but most people write the old C++ and don't try to learn the new C++,
Mm.
and they get with patterns and designs which even the committee on himself can say that there are errors. I mean, if we talk about some of the design patterns that and these decisions that happened in previous standards with C++, there are some interesting concepts that happen and they try to solve. But yes, sometimes users just don't think that you just learn a programming language and you don't have to do more. Sometimes, mainly
Hmm.
with programming languages that are like this, that have standards and all those, you better keep learning.
Yep.
At least for yourself. If sometimes not, because after all, well, there's people who do programming because they like it.
Hmm.
Here I am, and sometimes there's people who do programming and they are good at programming, but they do it because of the money. That is completely understandable and it is completely valid. But I think that oneself should often try to learn what is happening in the sphere and what
Hmm.
is happening, and should try to explore the new options.
Hmm.
And I'm not saying, okay, you have to write Zen-C now. Now that, okay, it's the new language, or at least with systems programming, in the systems programming world, this doesn't happen that much. But in web development, with the, okay, this is the new framework, this is the new. I'm not saying you have to learn the new thing all the time, but you have to be curious, I think. And
Hmm.
I mean, I am not an expert about this, as I said. I am just someone like you all trying to learn and trying to being curious about this.
Hmm.
But I think that it is. It is important to see what the new languages and the new standards from languages have to offer. For example, here, because I didn't have time, I used malloc. Perhaps this wasn't the best idea. Perhaps I could use an arena, which I have an
Hmm.
STD. I have a library for arenas, or I
Hmm.
could use specific implementations. For example, now that we're talking about Misra C code, this wouldn't compile with Misra C, the
Mm.
compliance. We have a flag for Misra C compliance because malloc is quite unreliable.
Mm.
It's always check for null. In fact, that's a bad practice I just did here. I didn't check. That's on me. But um, but yeah, it is important to, for example, just with malloc, there's some or there are specific patterns or functions in C or in C++ or in other programming languages which exist and they are widely used, but that doesn't mean that you have to use them or that
Hmm.
you should use them. And for example, here I use it because I am used to doing this, but there are
Hmm.
things that I should learn myself and teach myself to change. But well, this is not for production, so either way.
I
But
think it's
here,
that's an interesting topic about, especially languages. You know, large languages. You mentioned about Bjarne Strusup. I mean, I think he's very well aware of the flaws and of the language. But he also understands the history of where they've evolved, where they started from C, and so on. So I think folks would be surprised his reasonableness of these things. But getting to your point of, when you start a language, especially a large one, or even a language like C, which we'd consider small,
Yeah.
still has a lot of features, extension, underscore generic, like you mentioned earlier, that I think a lot of folks don't know about. I think it's okay to just focus on a subset that works for you,
Hmm.
and then expand outward sort of as needed. It's a hard like cognitive thing to tell yourself, oh, I don't know all of it, but I still have to keep going.
Yeah.
So I'm glad
I
you
mean,
mentioned that. I think that'll be helpful.
it would be lovely to learn everything, but I can tell you, Linus Torvalds doesn't know everything about Linux. Jan Strauss doesn't certainly know everything about C++. And I, even though I am currently maintaining this, I will certainly at some point not know everything or forget stuff about Zen-C. And that's understandable. But what matters here is just both trying to learn, but not, as I said before, not going for the new thing always, but not staying with the old thing that can be a bad practice, but still a known one. Here, but it is definitely interesting. For example, about C. In C, I like to think of C as two possible programming languages. You have C as the standard, but then if you try to explore what happens with the compiler extensions, you will find a totally different programming language. For example, in GNU-C or in Clang, you can write lambdas. You could create lambdas, kind of lambdas in C, which it sounds weird, but yeah, you could do it. For example, in GNU-C or for the GCC, you can have nested functions, which is quite useful, but it comes with some problems, mainly with the fact that, if I'm not wrong, the stack turns executable. And that's not, I mean, it shouldn't be like the compiler will warn you, and perhaps you can be a bit scared. And sure, it can be a security issue, but still, you could achieve lambdas with GNU-C, or for example, in Clang, you have Apple blocks, which, if I'm not wrong, use a weird use a weird syntax. They use this symbol as the operator for Apple blocks. I don't know. I will check. You can find them online. The sources for this. Okay, this is. But yeah, you can achieve many things. There are many keywords, but the problem here is again is that portability. You can use that, but it will work for GCC. It will work for Clang, but then good luck with the rest. Um, as a rule of thumb for C, if it works in, I don't know, GCC, Clang, TinyC, compiler, TCC, or to be honest, if it doesn't work in the MSBC, it's not that much of an issue, to be honest, because let's just say,
Yeah.
I think, in fact, Sensi compiles in GCC, in Clang, in TinyC compiler. I haven't tried in GVC compiler, but I've been told about it. But it even compiles with C compiler. Uh, but no, it doesn't compile with the Microsoft, the Microsoft C compiler, the MSPC.
Is that because you're
Why?
using extensions somewhere? Or... I see. No.
Yes, yes, yes.
No.
And but that's interesting because when I tried to make it work with MSPC, I found out about many features in the language that I thought that were part of the standard and ended up being part of compiler extensions, but are just extensions that you can find everywhere. So everywhere they have them implemented. Or it is also interesting, for example, this. You have size of, okay, that works fine. But there are, for example, to type of that doesn't work.
Hmm.
I think there are some keywords like this is how close they get to the standard that I think there were some keywords that were implemented in a specific standard and they were removed. And if you go to that specific standard to compile, that keyword stopped working.
Right. Right.
So that's troublesome. But I mean, while I think that portability is really important, I have gotten people like saying to me, um, change this identifier because it's not supported in the Windows runtime.
Hmm.
And I'm like, okay. But then I check because I'm a Linux user. I about C and the specific Windows, how it works with Windows. I'm not really that used with to it. I have received help from other people from the community
Hmm.
to write the specific parts of the code that make it work with in Windows, for example.
Hmm.
But for example, I remember there's this thing. I was like, okay, the Windows runtime, or I don't exactly not remember exactly how it was called, Windows runtime or something like that. And I would check, and right now they use the universal, say runtime or however it is called. I
Hmm.
could check the specific term, but the problem is that the previous one, the one they were telling me about, it stopped being supported like years and years and years ago. And the
Oh wow.
current systems, except if you are in, I don't know, Windows 7, you will you might have issues. Although I don't know if in Windows 7 it's. I know that it's in all Windows operating systems, and I'm
Hmm.
like, I understand this, and perhaps we could take this and see what we can do about it. But I have many books to check. I have many issues to solve, and perhaps why are you using Windows 7 or why aren't you using Windows XP or
There's
something
still
like that?
people. Yeah, there's still people.
Yeah, I mean, I understand it. I understand if you're using
Yep.
Windows 7 over Windows 11, but
Well, I mean, maybe that's a good, transition to thinking about for Zen Z. What does the sort of roadmap look like as far as features and how you're making these decisions about what is important to focus on? So, I know you have a roadmap on the website, and I was wondering if we could kind of
yes,
check that out
yeah, we can do that.
and then and then maybe we'll start looking at if folks who are watching on the live stream, if you have questions,
Yeah, sounds great
we'll
to me.
try to feel free to start pouring in some questions, and I'll try to get those answered before we end our chat here.
Yeah, sounds
But
great.
let's see here. So let me open up. I'll open up on my end here. I think that'll be easiest to just share.
Okay.
And then let's see here. We'll do this. All right. All right. Let's do that. Because it looks like there's some exciting
Yeah,
things
there's some
coming here.
interesting
So,
points.
and the development's moving, quite fast as well. So,
Yes.
let's see. I'm just going to take us down. So, if folks haven't seen the website, definitely check it out. I think you've got a newsletter here for folks who want to kind of
Yeah,
keep an eye
well,
of what's coming. Um,
yeah. This is
uh,
I changed the website a bit since we last since you did the last video. I think
mhm.
it has some interesting things like well, for example, I mentioned the Rosetta code
Oh
examples
yes,
here.
yep,
You can
yep.
press. This is important. Here I have some community videos. If you come here, for example, well, first of all, if you come here, you can see, for example, your other video
Hmm.
about Zen-C, and you can find other videos, for example, from the person I mentioned earlier who was making the web browser.
Mm.
There's one in the middle. He made the web browser, and then you have Game from Scratch, which is I think
Hmm.
many of you might know this channel.
Hmm.
And well, now below over here, like down here, we have the different points,
Hmm.
and well, this is interesting. I have to say, I haven't updated this since perhaps a few weeks. So perhaps I will read this and they will say, okay, we have moved from this, or we have already achieved this, but let's see. Zero overhead, C transpilation. This is where we are right now. This is true to an extent. I mean, this is 99% true. It is true that, for example, in some cases, I have to introduce a specific virtual tables or other things for specific features. But I try to focus mostly on the weight of the. I try to focus mostly on having Zen-C produce C code and having the time spent on the compilation time and not in the runtime. Because, sure, for example, this is also a criticism I have heard a lot about Rust and so Rust specifically. I don't think that happens that much right now, but I have heard the criticism about Rust taking time to compile and everything. But I think some languages, or I think that the language, it shouldn't matter that much, although I think it is important that it compiles fast. But if you can sacrifice some compilation time, like for it to take longer, so the runtime is faster, or so it has to do less things in the runtime, it is definitely worth it. But yeah, I most of the abstractions that we have are zero cost abstractions, and well, the compiler is being improved day by day. In fact, even today you can see that it has received the changes and everything. I am working on it all the time, but it will just get better and better. But it already has a lot of zero cost abstractions. Then we have interoperability with other languages. You can see here C++, Objective C, CUDA C++, in fact, this would be because there's CUDA C and CUDA C++. I could implement it for CUDA C, but when I did it for CUDA C++. But it's doable. It's just pretty much, as I mentioned earlier in the live video, and well, I will mention it fast again because I'm sure that some people maybe didn't hear it. I treat C as a protocol. And many programming languages have a layer of interoperability with C. Say C++, say Objective-C, say CUDA C++, CUDA C, Lua, D, many of these languages. So instead of having to write a compiler that code generates C++, Objective-C, all this, which would take a lot of time, would literally be rewriting the compiler, I can just use, for example, specific keywords like extern, and well, it depends on the programming language, how they have defined that interoperability, but it allows me just to have C code that works in the programming language. So it would work with C++, with Objective-C and CUDA, and this list is not exhaustive. Like, I haven't implemented it for many other languages, but it is possible. It is a quantitative issue, not a qualitative issue. If I put time, I could make it work with many other programming languages. That's why I love C. Then we have RAI resource semantics, which is quite useful, mainly considering the kind of issues that we can find in C with how we use, for example, malloc, free, and we can end up with memory corruptions, segmentation faults, memory leaks, and all these issues. With RAI, it just works. I won't explain that much because you have explained it really well in the other video. But same with monomorphized generics, which in this case it's pretty much like I said before for impl blocks, but in this case for generics. In this case, it would be a normal C function once transpiled, but it would be with a specific name, like it would be the name of the function, say new, say this function, say foo, whatever. And with, for example, the name of the new type or whatever. But yeah, it would just be a C function under the hood. You wouldn't have that many issues. It's that easy. Then we have the LSP, which I mentioned before, and the Ape. You checked this the other time, but this is really useful because Ape is like it allows you to have a binary, which is it's a polyglot binary, if I'm not wrong, in the
Mm-hmm.
sense of it adjusts itself depending on the different architecture and the different operating system, and it can just work with huge list of a huge list of different architectures, different operating systems. One issue that it has, it's that you cannot have code. For example, you cannot use macros to say, okay, this is Windows, this is Mac
Mm.
OS, this is why? Because the macros would just delete that code. But
Mm.
this has to have all that code. So it has to decide that during the runtime whether or not it is Windows, whether or not it is FreeBSD, whether or not it
Mm.
is Mac OS, many of these, which requires me to rewrite a bit the code base, but it's not that much. I mean, they provide you the specific functions and everything, and it's just changing the specific macros to the specific functions. It is fine, and it gives you all these architectures and all these operating systems for free.
Mm-hmm.
Now, if we go to the system expansion, the package manager, it is something that many people have told me about.
Mm.
Mainly, I don't know if it is because they like package managers or because they like Rust and they think, okay, this is Rust. I cannot beat the Rust allegations. And, uh, I don't know. I think they want a package manager. I am not against it. I am not pro it. I'm neutral with it.
Mm-hmm.
I know that other creators, like I've seen Ginger Bill, the creator of
Mm-hmm.
Audi, who is quite against the package managers.
Yeah.
And it's a matter of this taste, architecture, and design, but it is something that I'm not closing the door, and it is like I thought it could be a possible next step. So that's why I added it. I haven't worked anything about it. So right now, I wish I could show you some stuff about it, but it could be, for example, in the next months if I ended up implementing it. Then we have
Package
WebAssembly.
manager.
Yes.
Oh, I was gonna say package manager is sort of an interesting, and as you said, a very sometimes controversial, decision to make, because if you look at languages like Rust or Python, where it's been very successful to just pip install or cargo, build and so on, and have that uniform official way, or in D it's dub, that's kind of nice. But then you have C++, which has you know make, pre-make, Meson, all these build systems, VC package.
Yes.
So I wonder if this is just where does the community want to place the complexity, or if they find some advantage, or just to have a single source to sort of look at stuff and have, sort of blessed packages and libraries. So it's interesting because I also resonate with Ginger Bill's take on package
Mhm.
managers. So, but I'm at the point now where I think C++ would be lovely if there was just one that
Mhm.
folks could sort of
Yes, I
use.
agree.
You can always build your own, nothing wrong with that by
Mhm.
yourself, but having one, I guess this is something you are going to have to wrestle with here.
Yes, definitely. I
Okay.
mean, if you check the source code, like the repository, and we don't
Hmm.
need it right now, but if you check it, just already, I have like three different. I have a build path, I have a make file, I have a CMake lists .txt, and I know that that will keep growing. And I
Hmm.
know, for example, I've seen people, for example, adding a specific files for Nix OS on many of the other things. And after all, I think one thing that is beautiful, both of like Linux, which is it also has these issues, let's say this,
Hmm.
and the programming languages is that first, sure, you can make your own, and it is great. If you want to learn stuff like we were saying before, just try. For example, how does a package manager work? Write your own package manager, but that doesn't mean that the language should have 100,000 package managers. And for example, that's something that I will have to see because I certainly just want to have like a core, like sure you can make whatever, but I want something that to be the source of truth.
Right.
So we don't end up with for example, tutorials or sources that use different dependencies that maybe don't work between each other. I think
Mm-hmm.
that it should be as simple as possible.
Right, right. Now, looking at the roadmap, I see there is some stuff about compile time reflection, and there's a question about um, in the chat about will Zen-C be able to read files at comp time. So I guess this is specifically talk about reading in files or maybe like an embed type of thing that C has. Is that something on the roadmap or that is supported already?
This is great. The thing, I don't know who asked that question, but that question is great. Um, in C23, as you were saying, they introduced the embed keyword, which
Mm-hmm.
allows you to, for example, take a file and just embed it, as it pretty much says. In this case, they didn't lie with the name. And this we introduced this. I have introduced this in Zen-C. In fact, it is interesting because it's one of the few first features that I introduced in Zen-C. Mainly because when I started with it, I was thinking of Zen-C as a preprocessor, and Embed is a preprocessor directive. So I was like, okay, what if we make this? So instead of having to write, instead of using it with C23, which many people don't use C23, we could just go and use it for C99 or C11, or whichever. And well, it works. You can use it and it embeds the file. I think it is defined there in the documentation, and it works fine. That's a great question. Related to comp time, so the main issue right now is that when I implemented it, I was implementing 20 other things at the same time. So I wanted to focus on just having like being able to for it to read text and output text, kind of like the plugin system, but not exactly the same because the plugin system, I think that design pattern that it's kind of like Unix is like input output, we have these streams of just deal with the std out, std in, but I think that's good for the plugin system for the flexibility it can give. It can cause issues. I mean, sure, we could offer the AST, but it is useful. But for comp time, I will surely move for more less flexible and less fragile.
Mm-hmm.
Uh, because after all, that's the main issue with this. It is quite fragile. I remember you were trying comp time in the other video,
Mm-hmm.
and the main issue that perhaps I will need to improve the documentation about it is that it pretty much just what you print there, what you put in the std out, it's what gets in the std in, what it gets inside the file.
Mm-hmm.
For example, if you do print line and then inside you put print line whatever, then that what's inside of that it's what is going to appear later in the file. I don't think that's good. That's something. That's one of the things that I wanted to tackle, to explore and to improve, and to see what I can do about it. But current comp time, it is not definitive. It will be improved. I will work on it. Expect changes in these future months.
Great, that's exciting. Yeah. Any feature you want to highlight before we get up to the sort of wrap up about
Mhm.
things in the maybe let's look at the ecosystem expansion. I mean, these are all big
Standard
items, but
library.
is there anything that you're kind of working on now, or is really on your mind as far as taking up your sort of thinking of these items?
Okay, so right now about ecosystem expansion, well, I am currently thinking about, obviously, the problem is that I don't want to expand that much the standard library, or for example, because after all,
Mm-hmm.
the point of Zen-C is that I have C, they have the whole C environment. I don't
Mm-hmm.
need to, I mean, I can use Zen-C to create some good, for example, the string as we were using before, which can be
Mm-hmm.
useful, and we cannot achieve that in C the same way, and many other things. But in general, just use C. I
Mm-hmm.
don't want to grow the standard library that much. Railleaf works. In fact, Relief. I love Relief. I've been saying that all these time. By the way, I think they released this week the Relief 6.
They
Uh,
did, yeah.
yes, yes, yes. Um, yeah, Raysan is a great guy. I have to go with him, and yeah, it's I recommend Relief if you are into game development, and you have many other libraries. You have a huge ecosystem. That's the point of C in that way. So I don't want to focus that much on it. Sadly, what I will focus on is the WebAssembly, which you can already use with mscripten or with Clang. I think Clang has a specific option in a specific
Yep.
version to produce WebAssembly, yes. But I was thinking, and this is something, another side project that I've been working on, I've taken the TinyC compiler, and I was working on, instead of having the quotient be x86 64, for it to be WebAssembly. It is not so ready so far, but it kind of compiles already simple programs, and with time, I think it could be useful. Mainly, regardless of Zen-C, because I think that TinyC compiler with a Cothian patch for WebAssembly, I think that would be useful regardless of the language. But yeah, that's something that you will certainly have to look forward. And besides that, currently, what I am focusing right now is that, as I said before, I have certain extensions, I have certain patterns that I think we could remove. Not because they are bad, but because when I started, the compiler wasn't as robust and as ready and as extended as it was before. For example, for let, which as you can see, you don't have to define the type. You can do it, but you don't have to define the type. I use, in C23, I use auto, and this in other standards, I use a Genius C extension, which is available in practically TinyC compiler, Clang, C, not in Microsoft, not in the Microsoft one, which is autotype. And autotype is really useful, but it is an extension. But right now we have, for example, we have a type checker, and the type checker already knows the types. So instead of using autotype, I could just rely on the type checker. And that's it. Back then I didn't have I didn't have the type checker, so or at least it wasn't robust enough. But now it is. So it's my idea is moving some of the extensions and of the patterns that I took in the past and use what I currently have for the code to be completely standard compliant. That would be the main point.
Brilliant, brilliant. Well, that's all exciting work that's coming up, and it's been great to hear how excited you are about working on the language too. I mean, I think that's been infectious this whole time.
That's what matters the most to me.
So I want to do a few just rapid fire questions. First thing that comes to your mind as we kind of close out. I'll keep an eye on if anybody has any last minute questions. Feel free to pop those in the chat. But we'll start wrapping up. We've been here almost 2 hours going at it, which has been awesome.
Yeah, it's been fun. It's been great. But yeah, I mean,
let's see.
I don't know.
Oh, go ahead. Yeah.
I don't know. Well, I don't know what kind of, because right now I'm not seeing the stream, but if any kind of question, seriously, I am, even if you think that it can be dumb or it can be not interesting, I am here, and perhaps I am the best source to reply to it. So, and if not, well, you can always text me, you can always email me, and I will certainly reply. And if not, I am just, I am debugging the compiler.
Awesome. Well, let me shoot you this first question here. I think you've already touched on some of this, but what's a programming book, video, article, something you think every programmer should read?
Well, if we are talking about C, read the C programming language second edition. Like, I think that's the Bible. That has to be your Bible if you start with this. Why not read the first edition? Because the first edition wasn't part of the standard. Like, the standard didn't exist yet. So that's what they called K and third C, I think. But no, read the second edition, which is Zen-C. Perhaps it's all C. In fact, the B example I showed earlier without the int type, um, you will also see in the book, because at first C you could if you didn't put the type by default was int, and many other things. You will find patterns that designs and features that sadly won't work in Model C, but it is still C, and it is something that you should start with. And I mean, Richie and Kernigan, I think, I don't know how to pronounce it, wrote it.
Mm-hmm.
Those are like the fathers. So take it for granted. Then, as I said before, the crafting interpreters book, it is just great. You can read it for free if you read it online. Although, as Mike said, it is so good that you should sadly have to buy it because it is really that worth it. And I don't know. I will mention an extra addition.
Mm-hmm.
I don't remember the book the name exactly, but it was written by the creator of Forth, which is another interesting programming language
Mm-hmm.
that it is quite exotic. And if you don't know about it, you should check it because it will certainly blow your mind. And it is about, I think I don't remember if this is the title, but it goes around what he calls as problem-oriented programming. And I think that's interesting to read. And sure, it is an old book. It's older than B. It's older than all these things. But I think it's interesting if you have time and you want to see other paradigms and other ideas, explore that.
Excellent. Let's see. Advice to young programmers just getting started.
That's something that I should ask for. Um,
Well, what's worked for
well,
you? Yeah.
well, what has worked for me? Just be curious and try not to care so much about what other people think about my code and what other people think about, because sometimes you write something but you are like, this can be improved. This is not red enough. Some people will see it and will be like, oh, this is spaghetti code, or this is what. If you sadly saw most of the proprietary software, and maybe not even proprietary software, if you took your time to see most of open source projects out there, you will see that sure, there's people with knowledge writing them, but they are not as robust as you think they are. So many times it's just put your time, put your idea, try to work on it, and just do it because you want it. Do it because you're interested. Because after all, if you're here, you're either for the money, and then if so, go and study hard and work hard for it. And if not, although it can also, money is always helps in these things. But if you do it for passion, which is, for example, my case, just take with it whatever idea, whichever concept that you think, okay, this sounds interesting. How do I do this? Do it. And for example, there's a lot of people who are against LLMs or things like those. I think they can be quite useful for learning concepts, for asking ideas, for asking, okay, how does this work? They can be really useful in that sense. They don't. I think some people don't understand how great of a teacher they can be. Obviously, you have to check other sources. You have to take your time for verifying. But same way as you would take a book, you would certainly have to verify the sources in the sense of it might be wrong, or in what happens with other many programming languages is that perhaps it worked, but now 2 years later it doesn't work, or a year later it doesn't work anymore. But yeah, be curious. Just be curious. That's more than enough.
Excellent. Excellent advice. Do you have a favorite game? Could be video game, board game, something you'd like to share?
That's a great question. Ah, Fallout. Fallout, it's a great video game. Well, if I'm not wrong, I have to verify this. I don't know if they were written in C++. I know there's a Fallout script language or something like that. It is proprietary. I don't know much about it. That's the problem with video games, that they are interesting, but in terms of software, you except if you are talking about a video game like the first Super Mario Bros. Or something like that, good luck reverse engineering it. But yeah, Fallout, and I don't know why. I started playing it a long time ago, which is something that perhaps I shouldn't have done, but it is really important for me as an experience. And also talking about Fallout, the creator has some great videos. Well, the co-creator, I think there are two main creators, has some great videos about programming, and he talks about his experience about writing the first Fallout and the second Fallout, I think. And you could
Mm.
check that because that will give you a view of how those projects and how well how programming actually is in a real living way. Because sometimes we see the tutorials, but if we understand how, for example, for a project, a team, it can be to release a game and all the software issues and all the issues between the designer, the programmer, the you will see that there's a lot more about this than just the coding.
Excellent, excellent. I'll have to check that out myself. I didn't know that about the creators. Let's see. So another question here. First time you saw something on a computer that made you go, "Wow."
Ooh, that's I mean, I could say whatever, but I want to find something that actually means. I think so about computers. Well, I think we take many things for granted in terms of computers. Uh, I recommend you, well, every one of you, that perhaps take away the ideas you have of a computer right now and just explore weird, esoteric, and obscure architectures out there. And you will find, for example, you will find computers. Well, by definition of computer, in the ancient Greece, there were already computers. There's the Antikythera mechanism, which is over 2,000 years old. And
Mm-hmm.
there's the you have computers that are analog, which means that you don't have one and zero. Then you have in the Soviet Union, I think they have computers that were trinary, so
Mm-hmm.
they didn't have just one and zero. You could explore because also something that it is often mentioned, quantum computers. There are many things out there, and perhaps we have a too small definition of what a computer is. A too and I think that when, for example, if you ask me what made you think, what made you go wow about the computers, I think it's just thinking about how many variants and how it, how much it can extend and how many things can change. I think it is really interesting. There's a you will find. I mean, if in the history of hardware, history of computer, you will find, for example, solutions that or hardware that was better, but it was perhaps under a specific license and it stopped being developed, and we went for something worse, or for things like those, or we went for something cheaper, or things like those. Don't take what you have for granted. There are many things that could have happened if many things went different, and I don't know. I think it's fun to explore. If you want to read some of that kind of stuff, you will find a lot of surprises.
Excellent, brilliant. Well, with that, I'll end our sort of rapid fire questions, and I just want to give you the last word before we end the stream here. And
Mhm.
thank you again, Swet, for the opportunity here. It was absolutely amazing to learn the history. I suspect there's going to be more searches for the B programming language coming up, and
Yeah,
I
I
just found
think.
that fascinating. So let me
Yeah,
let you
it's
take it away
definitely
here.
fun. So first of all, for everyone who's watching this, or for everyone who will watch this, um, I'm not. I am the creator of Zen-C. I am a C developer. I am a systems programmer, we can say. But I am just another person like you. You can make this. Sure, perhaps it can take time. Perhaps it can take effort. Perhaps it will make you suffer because these things is what happens with these things. But there's no barrier between this and what you can do. You can clearly do this. So regardless of what you do after what you watch this video, either you try and see, either you decide, okay, I'll write my programming language, or okay, I will research about this. Just do it because I know that you can do it. There's no limitation. Many times, I think there's this anecdote. um, I don't remember the name. This happens so often to me. But there's this mathematician or a student of mathematics who went late to class, and there was a problem in the blackboard, and he thought the problem was homework. So he solved the he solved it for home for giving it to the teacher. He solved the homework, and he was like, "Okay, this is hard, but with time I can solve this. I can take my time, and I can do this." And when the teacher saw what the student did, he was speechless because that was a really long problem that was not solved. And I think it is really important for you to have that positivist uh, mindset. If no one else did it, you can just do it. Why can't you do it? So write a programming language like Zen-C, or write whatever else, and you will surely be in this channel if you do. I mean, after all, it's just that. Just do what you like and keep going.
Excellent. Well, thank you everybody for joining the live stream. We appreciate your time and attention. We'll hope to see you on the next one. And again, thank you so much for your time. And bye for now, folks.
Bye bye. It was an honor.
All